Hi, my name is Sri Lakshmi Raghav, and my project is the assessment of coconut graphene oxide manganese catalyst on microplastic degradation. Microplastics are small pieces of plastic debris found in oceans and aquatic systems, as well as cosmetics and clothing. These plastics pose a threat to human life and marine life, and also have caused a significant enough problem for them to be classified as contaminants. Peroxymonosulfate has been used in the past as a way to help degrade contaminants such as these microplastics. The thermal activation of peroxymonosulfate creates sulfate radicals which help in the degradation of these contaminants. Catalysts can also be used to enhance this process to help further degrade microplastics. In my project, I created a coconut graphene oxide manganese catalyst for this purpose. To make the coconut graphene oxide, I first burned coconut husks to create coconut charcoal and then heated the coconut charcoal in a tube furnace at 400 degrees Celsius for 5 hours. I then washed and dried the final product to make the coconut graphene oxide. For the coconut graphene oxide manganese catalyst, I took that graphene oxide that I had made and combined it with manganese chloride and isopropyl alcohol and placed the mixture in an ultrasonicator for 30 minutes and then refluxed it for 30 minutes at 80 degrees Celsius. I then added potassium permanganate to the mixture and continued refluxing for 1 hour. After refluxing, I filtered and washed the final material and then dried it in an oven at 50 degrees Celsius to get my final graphene oxide manganese catalyst. To obtain the microplastics, I got it from Facial Cleanser, which was the source that was readily available to me. For my project, I used 2 different brands of facial cleanser. I first diluted the facial cleanser in DI water under magnetic stirring at 60 RPM for 24 hours, and then I washed the facial cleanser several times to obtain the microplastics, and then took the remaining microplastics and dried it for 3 days, and did the same steps for the second brand. For the microplastic degradation, I took the microplastics and combined it with the catalyst and the peroxymonosulfate and put that in the DI water, and then put the samples in a constant temperature water bath at 40 degrees Celsius for various amounts of time, which I chose 2 hours, 3 hours, and 5 hours. After putting it in the constant temperature water bath for these times, I took it out and cooled it to room temperature and then filtered out the microplastics. I then used a mass loss percent equation to see what mass percent of microplastics were degraded in each sample. I then repeated this for the second brand and then got my results. In my results, I found out that the catalyst did help more effectively degrade the microplastics than the control, which contained no catalyst. I also found out that as the time increased, the catalyst more effectively degraded the microplastics, so the 5-hour catalyst sample was the one that had worked more effectively with a 16.5% mass loss. I also performed FTIR analysis and XRD on my coconut charcoal, my coconut graphene oxide, and the catalyst to confirm the composition of those substances. With the FTIR, I found that through the peaks, these substances were formed, and I also found that for the coconut graphene oxide, there weren't very defined peaks, but after more research, I found that what was actually made was reduced coconut graphene oxide, which actually helped my project more because reduced coconut graphene oxide has less oxygen groups in it, which helps it become more stable. With the XRD, I found that the coconut graphene oxide and the coconut charcoal were formed through the peaks that were shown in the XRD, and then the XRD for the catalyst, I found that the coconut graphene oxide peak was shown and there was a slight manganese peak, but I would have to repeat this XRD for the catalyst to see if there was a more defined manganese peak. In future studies, I'm planning on testing my catalyst in other conditions such as changes in pH, changes in temperature, and changes in catalyst concentration to find the optimum conditions for which this catalyst can help effectively degrade microplastics. And I'm also planning on doing SEM images on the microplastic degradation before and after the experiment, and also doing SEM images for the coconut charcoal, the coconut graphene oxide, and the catalyst to see the structure of these substances and also see the degradation of these microplastics. I'm also planning on doing elemental analysis in XPS to further confirm the composition of the coconut charcoal, coconut graphene oxide, and the coconut graphene oxide manganese catalyst.